Ladies and gentlemen, welcome to our second technical video. This short video presents a Python code that was built for electrical submersible pump data visualization and performance analysis. The Python code allows for a simultaneous display of the high-frequency ESP data, allocated data from OFM production database and the Eclipse simulation results. It also enables a direct update of an existing Prosper well model through open server connection. Let us move to the tool interface. In the first tab, the user can select a well for further analysis. The drop-down button shows the wells equipped with an electrical submersible pump. Selecting well 2, for example, will update the plots that are made to analyze pressure across the pump. 3 plots are proposed. The evolution of the pump intake pressure with time, the pump discharge pressure, and the pressure drop across the pump along with measured oil rate. The pressure drop across the pump is not recorded but calculated directly by the tool. The analysis of high-frequency data is facilitated by offering a time resampling option. This option performs a quick resampling the recorded data. The default resampling calculates a representative value every 24 hours. Recall that the original data frequency was 5 seconds. There is also a possibility to save the resampled data for classical spreadsheets. Finally, one can add a threshold line to each plot to better appreciate the data variations. The second tab consists of 4 plots with the time resampling option. The drop-down button proposes 8 available tracks. Here, G1 and G3 plots show the intake and discharge pressure variations. G2 shows the temperature variations of the engine and the fluid at the pump intake. The bottom right plot shows the frequency and intensity of the pump engine. The plots in this tab help the engineer to quickly verify and analyze the pump 8 recorded tracks at once. The third tab shows the well performance data. First, only one plot is made. The tested oil rates and the gas-oil ratio for well 2 are directly taken from the OFM database. The forecasted oil rate for well 2 is read from the Eclipse simulation results. The operating frequency of the pump is also plotted. A well model is separately built in Prosper to analyze the pump design and the well performance. The Initialize button is a direct call to Prosper through Open Server to run this well model and display the results. The main well model parameters are captured and displayed for further fine-tuning. In this graph, the performance plot is shown, along with the pump operating points, and the model input parameters. Note that the model parameters and the performance curve correspond to the pump behavior at a given time, that is, in this case, when the pump starts to function. The model may be updated with the last production data, 180 cubic meter of oil per day, 230 cubic meter of gas per cubic meter of oil and a pump frequency of 48 Hz. Clicking the Update button sends the new parameters to the Prosper model, runs the calculations and updates the performance plot automatically. This update shows that the operating point of the pump is far from the optimum range. However, the Eclipse production forecast shows that the oil rate is expected to increase to about 300 cubic meter per day in the future. Using this rate shows that the pump would be back into the optimum range. Please note that this short example does not intend to be rigorous. Its goal is to show the opportunity given to the engineers by such a simple, yet powerful tool.